Okay, we are going to talk about 0. Here is the number 0. This number 0 is this on the abacus. That's what 0 looks like. So if you notice, there's no items, there's no items here. So what happens is, after that, we have 1. There is 1 pig. So if you look, this 1 pig. Oh, I don't know if I can do that. Okay. That's what it looks like on the abacus. Oh, man. I need my mic. Oh. There we go. Hold on. That was a blunder. Okay, I'm hoping you guys can hear me now. Alright. So, hello, welcome. That was a newbie. Anyways, so this is 1. After 1, we have 2. Like we have 2 snakes. So when we look, we have 1, 2. 2 snakes, 2 beads on the abacus. When we look, we want to make sure that we have our abacus, and our abacus tells us where what's being counted. This horizontal bar is what's being counted. Because it's being counted, these are the 2 beads are being counted. So if I do this, these are all being counted, and this is what 2 looks like. 2, 2, 2, 2, 2, 2, 2. Now we have 3. This is 3. 1, 2, 3, like 3 chipmunks. So we do 3 on the abacus. These are all 3s. Let me know if you have any questions. And then we're going to do 4. 4 looks like this. That's a 4. These are all 4s. 4 koalas, 4 on the abacus. Well, 4 big koalas, 4 adult koalas, or 4 baby koalas. So when we look at it, then we have 5. When we look at the 5, 5 will always be the top bead. So the top bead is always 5. We have 5, 5, 5, 5, 5, 5, 5. And then this is 5, what is it? 5 horses. These are horses. So 1, 2, 3, 4, 5. Okay? And then we have what? We have 6. 6, it looks like sheep. 1, 2, 3, 4, 5, 6. So we're going to do 6. 6 just looks like this. 5, 6, 5, 6. These are all 6s. When the beads, thank you, Cup. When the beads are touching the horizontal bar, this is the horizontal bar, this is what's being counted. So when I look, these are all that's being counted. Does that make sense? Let me know if you have any questions. And we're actually going through this book. So in this book, we're starting to talk about how the beads look. We have 1, 2, 3, 4, 5, 6, 7. We have 7 crocodiles. So we have 7 crocodiles. What does it look like on the abacus? This is what it looks like on the abacus. 7, 7, 7, 7, 7, 7, 7, 7, 7. So that's what it looks like on the abacus. And so what we're doing is we're understanding how does it look? How are we reading the abacus? So then we have 8. We have 8 little bunnies. 1, 2, 3, 4, 5, 6, 7, 8. Excuse me. So that's what 8 looks like on the abacus. And then after 8, we have 9. We have 9 little, they look like cows. 1, 2, 3, 4, 5, 6, 7, 8, 9. So when I look, this is what 9 looks like on the abacus. Anybody have any questions? All of these are 9s. 9, 9, 9, 9, 9, 9, 9. Now you might be wondering what happened to 10. Well, if I do this, this is 9. When I do 10, we look like that. That's what 10 looks like. How does that work? It works because every column is a place value. Every place value has a number. So when we look, we have 1s, 10s, 100, thousands, and 10,000. So when we look, this is 10. 0, 1, and a 0. Just as we have written out like this. So when we look, we have a 1, and a 0. 1, 0. And then this is 11. 11 looks like this. 1 and 1. And then this is what 12 looks like. 1 and 2. We just started. Don't worry. Don't cry. Don't cry. We're right here. So what we're doing is we're learning how to read the abacus. And I'm so happy you want to learn how to read the abacus. Thank you, Maud. Okay, so we're going to still continue to review Because what we need to do is we need to understand how to read the abacus. We're all right, Maud? Are you still there? Because you're the only one commenting. So, I want to make sure that you are here. Yeah? Okay, good. Let's start. Let's do a review. Hey, Lulu, welcome. So this is 0, 0, that's not 0. This is 0. 0 means what? 0 means that none of the beads are touching the horizontal bar. So what we're doing is we're learning to read the abacus. The abacus is a math tool. Just like the blocks and the counting bears and all this and that. This is an abacus and it helps us count our numbers. The first thing we're going to do is understand how to read it. So when we look, this is 0. Why do I know, how do I know that this is 0? This is 0 because none of the beads are touching the beams. So then when I look, this is 1, like the 1 pig. Because we have 1 pig, it's just the 1 bead. So if I did 1, and I did all of these are 1s, so it would be 1, 1, 1, 1, 1, 1, 1, then that's 1. Thank you so much for the heart me. Thank you so much for the heart me. I appreciate that. This is 2. 2 snakes, 2 beads on the abacus. 1, 2, 2, 2, 2, 2, 2, 2. Make sense? And so we do 3. 3 is easy. How do we know? 1, 2, 3 chipmunks. 1, 2, 3 beads. So if I did these are all 3s. 3, 3, 3, 3, 3, 3, 3. And then we have 4. 4 koalas. It looks like this. 4 on the abacus. That's what 4. Yeah, 3 snakes, right? The 3 snakes, if I did it, it would look like that. That's what the 3 snakes would look like. If I did specifically 3, it would look like that. Make sense? So we have the koalas, and now we have to go through and add the 5. Well, what happens to 5? The 5, like the, what is it? The horses, right? This is all 5. 5, 5, 5, 5, 5, 5, 5. And then what's 6? If you notice, 6, 1, 2, 3, 4, 5, 6 is the sheep. We have 6. 5, 6, 5 plus 1 is 6. 5, 6. 5 plus 1 is 6. So these are all 6s. So we look at that, this is all 6. And then we have 7. Easy, simple to use, easy to understand. 1, 2, 3, 4, 5, 6, 7 crocodiles. So on the abacus, this is 6. We just need to add 1 more to the columns, and now we have 7. And then we have 8. We have 8 bunnies, and then all I have to do is just move all these beads up. So what happens is I have 3 on the bottom plus the 5. 3 plus 5 is 8. This is now 8. And then our final number is 9. Every column has 9. When we look, hey Carter, welcome. This is 9. 9 cows. 1, 2, 3, 4, 5, 6, 7, 8, 9. Make sense? See, Maud, you are not late. So when we look, we have our columns. Every column is a place value. So when we look, we have our 1s, our 10s, our 100s, our 1000s, our 10,000. If you notice, I start here, and I'm happy that everybody...
Now, open your mind to me, please. Open your mind.
So when we look, so I want to just, this is a different way of learning math. That's all we're doing. So what I'm trying to do is I'm trying to show a different way to learn math. And if we can look, we have our place values. Notice I have my 1s over here. So I have my 1s. These are my 1s indicator. I have my 1s here. If I choose this one like a Pokemon...
Pokemon, I choose you!
I could choose this one, right? But then if I do that, then I have my 1s and my 10s, but notice I don't have any 100s. However, if I choose...
Okay, Charizard, I choose you!
If I choose this one, thank you, Maud, for the popular vote. If I choose this one, hey, thank you, Pax, for the heart me. So if I choose this one, like a Pokemon, then I have my 1s over here. My 1s, my 10s, my 1000s, my 1s, my 10s, my 100s, my 1000s, my 10,000. Make sense? So when we look, you'll notice that because I have my indicator, the dot indicator is like a label. Oh, that's all it is. It's just a label. I choose you. Yes. It's just a label. So if I choose this one as this my indicator, then I can do this, which is my tenths, and then I have my decimal sits right between the 1s and the tenths, and then I have my hundreds. You could choose this one, but then you'd have a lot of decimals. You have a lot of placement for the decimals. Okay, so that is about using the abacus. When you use the abacus, you'll notice it's very easy to move. Because it's very easy to move, you want to use your left hand to stabilize the abacus. Ha 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 ha! Thank you, Maud, for the dolphin. So when we look, we want to be able to make sure that this is like a rattle, right? It's easy to move. Abacus division, I'm not sure. It depends on how the class is. We might be able to because there's not a lot of people here. It depends on how quickly we can go. If there's not a lot of people, then we can go pretty fast. Okay, so what we're going to do is we're going to understand that, if you notice the beads, right, the beads, there's some edges. So when you do, you want to be gentle with the beads. You want to be happy when you do abacus. We want to be happy when we do abacus, so then we can move the beads, right? So when we look, we're not going to be aggressive to move the beads. We're going to be gentle. We want to be gentle. It's not delicate because it's made out of plastic. It's not abacus. That's funny. So what we're doing, right, we want to be able to be happy when we do the abacus, okay? So that's one thing. The other thing is, please, don't flick too hard.
And flick. Oh, flick too hard, damn it!
Don't be like Zeus and flick too hard. Because if you flick too hard, then your answer becomes wrong. So when you do it, right, don't flick too hard. Make sense? Because it's very easy to move the beads. So you have to be careful with moving the beads. So we want to make sure that we're happy and we're gentle. And not to flick too hard. Guys, thank you so much for the hearts. Thank you so much for the hearts. Okay, how are we doing? How are we doing? Do we want to do, we got to keep going, right? Is Maud still around? I know Carter's excited for that division, but I want to make sure that we go through the process of adding, subtracting, multiplication first before we go into division. Keep going. Okay. So, we understand how to. I'm here. Let's do one more. Oh, no, there's plenty. I've got plenty. I'm so happy you're still here, Maud. So let's do this. Let's do a maze. This maze is a 2-digit maze. That means we're going to look at the abacus and we're going to see what number it is. So this is here. What is this crazy maze? So this maze is going to, what we're going to do is we're going to read the abacus. Every box is what we're going to do, is we're going to do the box. And when you figure out the number, then we can travel to a box. So if I have this number, can you see what number is this? Yeah, because we're starting here. What number do we think that is? So if I did this, I have this and this. So when I look, please put in the comment what number you think this is. And what we're doing is we're learning how to read the abacus. Thank you guys. Thank you guys. So what number do we think this is? Hey, Frieza. 49. Yes, Pax. Exactly. 49. 1, 2, 3, 4, and then 5, 6, 7, 8, 9. And when you look, I have my 10s and my 1s. So that's how we get 49. When the beads are all touching the horizontal bar, we have 49. None of these beads are touching. So Drowsy, when you said 40, 40 looks like this, where it's a 4 and a 0. 4 and a 0. So when we look, we have our 1s and we have our 10s. So the number we had was 49. So then we have this one. Oh, you can't see that one. What number do we think this is? That one and that one. What number do we think that is? Right? Right?
Welcome to the real world.
Yes. Hey, Balls on Budget, welcome back. Carter, Pax, Drowsy, good job, good job. So it is 57. 50, this is a 50, 50, and then this is a 7. 5, 6, 7. 5, 6, 7, 8. And then we have this one. So we have this, and then we have that. Oh, you can't see that. That's not right. Huh. What number do we think this is? Adrian. Adrian, you were reading other people's numbers. You weren't reading the abacus. 73. Yes. Well done, Drowsy, Sasha, Pax, Maud. Kay, welcome. Yes. Balls on budget. Yes. 73. 70, 5, 6, 7, 3. 1, 2, 3. Yep. Yep, yep, yep. So 73, right? And it will take us to here. No, not 100. Not 100. 100%. Good job. So we have this number, and we have that number. What number do we think that is? I think Adrian left, because I caught him cheating. Cheater. Cheater. Yeah, right? Oh, good. It is 40, because it's 1, 2, 3, 4. It is 40. This is what 30 looks like. Okay, so that's 40, and then we're over here. Okay, we're over here. Okay, what number do we think that is? So if I did this number, and then this is my tens, and then this is my ones, what number do we think that is? 20, 1, 2, 8, 5, 6, 7, 8. Yes, fantastic. Good job, Sasha, Kay, Drowsy, Pax, G. Almost, Jihan. When we look, we have 5, 6, 7, 8. And then this is 2. This is 1 and a 2. This is 20, right? So 20, 5, 6, 7, 8. This is 28. We have 28. 28. 28. We're going up. We're going up to this number. So if we look, this is our ones and our tens. So if I have this number and then this number, when any of the beads are touching the horizontal bar, they're being counted. So when we look, we have 1, 2, 3, 4. Good job, Carter. Yes. 70. How do I know? 5, 6, 7. Good job, Sasha. K. Neuro Spicy Mom. Yo. Thank you, Maud, for the dolphin. Thank you so much. Almost, Jihan. So when we do it, we have 5, 6, 7. So this is 7, and you got the 4. Oh, it was a typo. Yeah, see? You fat fingered it. Fat fingers. Fat fingers. Okay, good. Good, good, good. Good, good, good. Makes sense. I'm happy it makes sense. So if I did this number, this is the tens, and then this is the ones. Oh, you know what I should do? Maybe next time I should do something like this. Yeah, maybe instead of going on top, it should be on the bottom, like that. There we go. There we go. Like that. There we go. There we go. 42. Yes. Yes, exactly. 42. So when we look, we have 42, and now we're going to go over here. So again, this is the maze that I created just to show some bead recognition and to be a little bit more fun because it's kind of boring. Math is a little boring. So if I have this number, almost K. 5, 6, 7. Yeah. So that's 7, and then we have this number. Can we see that number? Or let me see if I can move it up. There we go. So we have that, and then that. What number do we think that is? 69. Yes, thank you. 69. 6, 5, 6, and then 9. 5, 6, 7, 8, 9. And there we go. And then we go like this. And then we have this number with this. Oh my god, I just joined like 5 minutes ago. Hey, Jubilee, welcome. Good evening. Good evening. Yes, 31. Thank you, guys. 31. How do I know it's 31? I know 31 because it's 1, 2, 3, 30. How do you do it? I'm confused. Jihan, we were just there. Were you cheating? So this is the ones, and this is 1. So we know 31 because we have our tens and our ones. We do 30, 1, 2, 3, and then 1. This is what 1 looks like. So when we look, I forgot. I knew it. 1, 2, 3, 4. And then the top beat is 5. We have 5, 6, 7, 8, 9. That's how we do it. This is 9. And then we have 10. And now we can count by tens. 10, 20, 30, 40, and then 50. The top beat will always be 50. Oh, that's it. Oh, this is easy. What number is that? Hey, Shantae. What number is that? That's too easy. Maybe I got lazy. All right, so we're good. Yeah, we're good. You're counting along so perfectly with the beat of my music here. That's funny. All right, so we know how to do that. We know how to do that. Okay, no, Jihan. When we look, this is 0. So we have 0 because none of the beads are touching the horizontal bar. When we do 1 and 1, that's 11. Do this, this is, okay, Kay, I'll see you soon. This is 12. Then we have 13 and then 14. When they do this, this is 0. And then I do this, this is 20. Good night, Kay. Okay, we're going to continue on. And this was a little bit about how to read the abacus, and this is for preschoolers. So this is about, bigger, which number is bigger, which number is smaller. So the first thing we're going to do is we're going to understand. Carter, I will put that in the books. How about that? Let me put that in the books. But I do appreciate your enthusiasm. Jihan. Okay, good, Jihan. I'll see you later. I hope to see you in my next live. 28 times that by 61. Okay. What are we doing? We are learning how to move the abacus. What does that mean? In mainstream math, we focus on the result. However, in abacus world,
Welcome to the real world.
we focus on the add-in.
This is the way.
This is the way. This is the way.
So what we're doing is we're understanding how to add. We're going to add this number. If I have 5, my question is 1. This is the way, right? My question is, how do I add the 1? Can I add the 1?
Yes, we can.
Yes, we can. So I'm going to add the 1. So my final answer is 6. We're not going to be like, how do we make a 6? It's, can we add the 1? I have to go as well, Bobby, back. Next prize. Yeah. Okay, Maud. Thank you so much for the gifts. Thank you so much for the gifts. I do appreciate it. And I'm very happy that you're enthusiastic to learn more about the abacus. Right? So when we do it, oh, I wonder who else is here. The girls. Oh, the girls are still here. Okay. So when we do it, we're going to remember that we're going to focus on the add-in. So here's my next question. If this is 7... No, that's all right. If this is 7 and I add the 1, I'm going to add the 1. Ah, thank you for the rose and the flower headband. Thank you so much, Carter. So what's my answer? My answer is 8. Why? Because I'm adding the 1. Does that make sense? Can we add the 1?
Yes, we can.
Yes, we can. Yes, thank you, Jubilee. My final answer is 8. So we did the 1s. Now we're going to do the 2s. That's not 2. This is the 2. So we have our question. We have 5. And then my number is 2. Can I add the 2? Can we add the 2? Yes, we can. So we're going to add the 2. My final answer is 7. Okay. Is Neurospicy Mom still here? If not, we're going to continue on going further into adding and subtracting, or we go straight into multiplication. Because I'm not sure where we all are. If we have some... Oh, hey, you're still here. Okay, we're going to continue on adding and subtracting. And then we'll go into multiplication, and we'll see if we can get into division. I see that there's 14 people here, so I just want to make sure that I don't leave anybody behind, because Carter just wants to push everybody forward. So we're going to do 3. When we do 3, again, the 5, right? And then we add the 3. Is there enough beads to add the 3? Yes, there is. So my final answer is 8. And again, right, these are easy. This is super easy. What we're trying to do is we're trying to show how to move the beads, right? Again, we don't want to we don't want to flick too hard. So if I have 5 and I want to add the 9, I want to add the 4, my answer is 9. Again, when I look at it, this is my number, and if I decide to flick too hard, then my answer becomes wrong.
And flick. Oh, you flick too hard, damn it!
So make sure you don't flick too hard. So again, now what are we going to do? If we know how to add, we will know how to subtract. To subtract is just means to move away from the horizontal bar. So we have 2. If I have 2, I go to the horizontal bar. When I subtract, I move it away from the horizontal bar. Does that make sense? So that's all it is. So what we're doing is we're showing if you know how to add, you know how to subtract. So it's the same thing, and we don't need to worry about any more strategies. The only strategy we need to know is understand that when we move it away from the horizontal bar, we're subtracting. So if I have 3 and I want to take away 2, I'm just going to move it away from the horizontal bar. Make sense? So we do that, we do 2, and then we can do 3. Once we do 3, it's the same thing. We have 4, we add the 4, and then we need to subtract. We need to minus 3. When we minus 3, we're going to take it away from the horizontal bar. Same thing with 4. 4 doesn't have a lot of questions. Why? Because 4 is the whole thing. You can have 9, and then you can take away the 4. And that's it. Right? So my final answer is 5. You could do, 4, and then minus 4. Okay, so we added the 4. Now what we're doing, we're going to add the 5. When we add the 5, it's the same thing. Right? If I add the 5, right? Can we add the 5? Yeah, we can. And my final answer is 5. That's what this is, right? So if I have 3, I'm going to do 3. Can I add 5? Can I add 5? Yes, I can. So I'm going to add the 5. My answer is 8. So here is the next one, right? This one is 4. So if I have 4, and I want to add the 5, can I add the 5? Yes, I can. So I'm going to add the 5. My final answer is 9. And it's the same thing with the 6. The 6, what does the 6 look like? If I do 1 plus 6, right, I'm bringing these together like that. That's what adding the 6. If I take away, I'm doing that. So if you notice, now we see a number pattern. We add the 6, we take away the 6. We add the 6, we take away the 6. We add the 6, right? And my final answer is 7. What do? We have 7. Well, if we have 7, if we have 1, and I want to add 7, I'm going to add these 3 beads, 5, 6, 7, and I bring it together. And my final answer is 8. When I take it away, I'm moving it apart like that. So my final answer is 1. Same thing with 8, right? 8 is 8. And then add 1. Easy, right? Or we have 1, and then we add the 8. When we minus the 8, we're taking away. And then we have a final one, which is 9. 9 can't do too much, right? 9 is 9. 9 or minus 9. 9 plus 9. That's it. So that's what we did. That is adding and subtracting. And again, this is the same thing, right? Minus the 5. So when I have my question, I have 7, I have the 1, and I'm going to minus the 5. Can I take away the 5? Yep, I can. So I'm going to take away the 5. My final answer is 3. Yeah, makes sense? How are we doing? All right, so that is about subtraction. Hey, Goblin Jr., why is the 5 the blue bead on the 3rd column? Or why do we start on the 3rd column? Oh, that's a very good question. Thank you for that question. Why are we going to do it? Why? Why? Who says that? Why? Ah, Michael McIntyre says that. Okay, so why are we going to do it? The reason why is because I have 2 dots. Do you see that? I have 2 dots. Right? But I got to choose one like a Pokemon.
Pokemon, I choose you!
So if I choose this one, then that will be my ones indicator. When I have my ones indicator, and my ones, my tens, but notice I don't have any more beads for hundreds. So, right? Does that make sense? So every column is a place value. Every place value has a number. When we look, here's my ones, here's my tenths. Why? Because this is my decimal. My decimal sits between the ones and the tenths. So then this will be all decimal down here. However, if
Okay, Charizard, I choose you!
I choose this one, then I can move all of my numbers here. So this will be my ones. My ones, my tens, my hundreds, my thousands, my 10,000. Right? So then we look, I have my decimal sits here, and then on my tenths, and then my hundredths. It's the same when we have a 13 column one, right? This is only 7 columns. With my 13 column one, because size matters, it just depends on how big the number gets. So if I choose this one, if you notice, I have a dot here or a dot here. Every grouping is a group separator, right? Is a group separator. So then I have ones, thousands, millions, billions, and trillions. I just assumed it was whole numbers. I didn't realize it was for decimals. Yeah. Yeah, we only do decimals. We can only do whatever's in the decimal, the numbers, but we don't do negatives. We don't do negatives, just so you know. We can take away from a bigger number, but we don't do negatives, if that makes sense. So because I have my trillions, if I wanted to track my national debt, that's not a big enough abacus. I would have to use a 23 column abacus, and this one is made out of bamboo. But I don't sell this one. This one's mine. And I've been teaching abacus for about 20 plus years. And yeah, if I wanted to track the national debt, I'd use this one. 10 million times 1 billion. If you're looking for this one. So, if you're looking for this abacus, I do sell it on my TikTok shop. Yep. And 100 columns. Yep, if you find a 100 column abacus, you might be able to find one, but I don't know. Alright, so that's what this is. And this is this is made out of plastic, and if you notice that the beads there's an edge to it, and we want to be gentle when we use the abacus, right? We want to be happy and gentle, right? It's not delicate because it's made out of plastic, but we don't want to be aggressive. We don't want to just be smashing it down, right? This is not, we're adults here. We want to be gentle. So you could use it as a massager, but I wouldn't recommend it. It's not the greatest thing. My kids used to use it as a car, and they would do that, but it doesn't roll as well because it's got too many beads to roll. Anyways, so but be careful, right? Be careful not to flick too hard because your answer will be wrong.
And flick. Oh, you flick too hard, damn it!
Also, because if you bump your abacus, then your answer will be wrong as well. So the best thing to do is to hold it with your left hand and to stabilize the abacus with your left hand. And that's what I do here. Don't flick too hard, right? Flicked too hard. Don't be like Zeus and flick too hard. All right, so we're back to here, Okay, we've done that. What if I need a bigger one. If you need a bigger one, you could try to string them all together. I'd love to learn multiplication, divide on the abacus. So would Carter. Well, it depends. How far are we understanding? I mean, we could go into it, but then if I start doing multiplication, will you guys get lost with the adding and subtracting? Because that's the first thing we need to do is understanding how to add and subtract. How are we doing? Do we want it? We could go forward, but you can't be yelling at me saying, this is too hard. I will not take it. How are we doing? What do we want to do? Is that what we want to do? Multiplication, divide? How are you doing, Neurospacey? What do you want to do? Do you want to do adding and subtracting? Or do you want to go straight into multiplication? Personally, I think, I'm ready. All right. I don't know if Neurospacey's still home. Is she still here? Okay. Going once. Going twice. Half asleep. I hope I put you into a nice rhythm to go to sleep. But I laugh too much. All right, let's do it. Let's see how this number gets, and we will go slow. I will go slow. The first thing we need to do is understand on the abacus, we are going to find our place value. To find our place value, we need to count our digits. To count our digits, how many digits are there? No way. Laughter is great. But the laughter can't put you to sleep. I have to not laugh. 5. No. Digits. How many digits? 1, 2, 3, 4. We're not counting the sign. No. We're counting this is the question. 28 times 61, because we're doing multiplication. 4. Yes, thank you. 4. Yeah. This is the question. Here's the question. Carter should have answered. He's asleep. All right. Sorry. Okay, let me focus. So this is 4. What we're going to do is we're going to count 1, 2, 3, 4. Right? So we're going to start in the thousands if you want to think of it that way, right? Why are we going to do that? Because we need to understand where are we going to put these numbers. You can put them anywhere, but then depending on where you put them, you could have it in the wrong decimal place, right? So does that make sense? I just hit 73. Okay, so so we know 1, 2, 3, 4. Why? 1, 2, 3, 4. So the next thing we're going to do is we are not going to do 60 times 20. We're not going to do that because our multiplication tables don't go that far. What we're going to do, right, is 6 times 2. 6 times 2. That's the first thing we're going to do. So 6 times 2 is equal to 12. Thank you, Carter. So I'm going to add my 1, and then I add my 2. What's my next question? Then I got to do, what we're doing here is what's called distributive property. Distributive property. Property. That's what we're doing. Distributive property. Okay? So then we do 6 times 8. 6 times 8. Is the image mirrored? No, it should not be mirrored. Right, it is 48. So we add the 4, we add the 8, we add the 4. If we add the 4, okay. Okay, Carter knows this, but we're going to look. This is 4, this is 8. Do we have enough beads to add the 4? No, we don't. This is where we need to understand how to make a 5. Right? So we jumped ahead and we didn't lay the groundwork. I'm laying the groundwork of why we need to understand how to make a 5. We're going to utilize this 5. To utilize this 5, we need to understand how to make it. So we know, yes, exactly. Go? Yes. So what we're going to do is we're going to understand 4 plus 1 is equal to 5. So what are we going to do?
You need modification! Modify!
So to modify this equation, what we're going to do is we're going to isolate the 4. Why? Because we need to add 4. We need to add the 4. We need to add the 40. Does that make sense? So we need to modify it. So we're going to isolate this variable. 4 is equal to 5. 5 is not balanced. We need to balance it, and we need to minus the 1. Does that make sense? So what we're doing, oh, thank you so much for the rose. So what we're doing is we're going to take this number, and we're going to substitute it with this. So when I look, this is 2. I want to add 4. I'm going to plus the 5 minus the 1. I'm going to plus the 5 minus the 1. The bottom, yeah, you're almost there. You're almost there. Okay, so we have the 4, and then we add the 8. So I'm going to add the 8. Okay? We're done for now. I'm going to cross this out. What's next? We got to count again. When we count again, and I'm going to change different color. because I like colors. 1, 2, 3. 1, 2, 3. So good, you guys are keeping up. You're keeping up, right? But don't forget, we jumped a few phases. So I'm taking it slow and fast, right? Okay, good. Okay, just making sure. So now, what do we do? We have 3. 1, 2, 3. We're going to do 1 times 2. 1 times 2 is what? I know everybody knows this. Everybody should tell me. 2. Thank you. However, when we do 2, how do you make it 2 digits? How do you make it 2 digits? We can do a 0 and a 2, right? So what does that mean? 0, 2. Yes. So 0, 2, not 2.0, 0, 2. Because we want it, it's like making time, right? So if the time is 9:02, or if the time is 10:03, whatever, you know what I mean? Like, it's like time. So when we do 2-digit month, 2-digit year, 2-digit day, right? When it's a single digit, we want to make it 2-digit. That's what we're trying to say. Okay, so we're here. This is 8. 5, 6, 7, 8. We need to add a 2. Again, we now need to go back to understanding our formula. Here is what we do. Here is a framework. Can I add the beads? Yes or no? Can I add a 2 to this? Yes or no? No. Thank you, Carter. No. No. Thank you. So now we go here. Can I use the 5 plus the 5? Can I plus this 5? Yes or no? Thank you for the follow. No. Okay. So in the next one, hey Mel, welcome back. The next one, thank you guys, is here. This is the formula you need to know. This is how we make a 10. Plus the 2 is equal to plus the 10 minus the 8. So we're going to plus the 10. 1, 0. 1, 0. Add the 1. We can do it. And then 0. And then we need to minus the 8. Plus 2 is equal to plus the 10 minus the 8. Take away the 8. Take away the 8. Then what do we do? We're done with the 2. Now we got to do 1 times 8, which is, we know, 1 times 8 is equal to 8. 8 is a single digit. If we made it a double digit, it'd be 0, 8. Did that made sense? Because I took it slow. I'm hoping it makes sense. There was a lot of formulas involved. So then we add the 8. So my final answer is, what's my final answer? My final answer is 1,567. 0, 5, 6, 7, 8. Yes. Yes. That is my final answer. So the only thing that we really needed to do was add the 5 and add a 10. Was worth waiting for day. Thank you, Carter. I appreciate that. I appreciate your patience. But it goes back to understanding. Oh, okay, Neurospacey. Have a good night. Have a good night. Sleep well. I hope you can sleep well. So what we're doing is we're understanding this abacus framework, and that's why we needed to know how to add the 5 and add the 10. So in abacus world, we modify how to make a 5 and we modify how to make a 10. Does that make sense? So what we just did is, if you know how to add the 5 and you know how to make a 10, then you know how, then you can scale it. So let's do another question. This will be easy. I tell you, this will be so easy. So we know this one. I think Carter knows this one. This one's an old one. I'll make new ones later. 1, 3, 5, 7, 8. Right? So my next question is this is what I'm doing. So when I go 2, when I have 2, can I add the 2?
Yes, we can.
So I'm going to add the 2. I'm going to add the 4. Can I add the 4? No, I cannot add the 4. So again, we go back to, can I add the 4? Yes or no? No. Can I add the 5? Right? Can I add the 5? Yes. So it is plus the 5 minus the 1. So I plus the 5, take away the 1. And then do I have enough for 3? Yes. Do I have enough for 1? Yes. Do I have enough for 1? Yes. Yes. Yes, exactly, Goblin. Yes. Plus the 5 minus the 1. Exactly. Right? So we did something hard. Now it's something easy. Make sense? So what we're doing is, that's what the formula is. If you notice, so if you notice, we make a 5. These are the pairs of how to make a 5. And then these are the pairs on how to make a 10. And we just kind of switch the two all over the place. Yep. Right? Okay, how are we doing? Goblin, I'm so happy you're enjoying this. Pitterlong, how are we doing? Switch them somewhere. Switch them everywhere. Oh, you know what was a really good one? Here's a really good one. Okay, here. Let me see if I can. This was a really good one. We did this one. Okay, let's start with what we call a two-digit equation. So we kind of know roughly, right? We kind of know how to make a 10, and we kind of know how to make a 5, right? So the first question was 8 plus 5. So this is easy, right? We have 8, and we want to add the 5. When we add the 5, what are we going to do? Well, we know when we add the 5, what we're going to do, it looks like this. Plus the 5, 5 plus 5 is equal to 10. Plus the 5 equals to plus the 10 minus the 5. So just as Carter mentioned, plus the 10 minus the 5. Final answer is 13, right? Yes, plus the 10 minus the 5. Minus the 5. That's what we're doing. We're not memorizing. We're not going straight to the result. We're going to understand how to do this. So instead of telling me what the answer is, tell me what I'm supposed to do. That would be how I know you understand. You know what I mean? So you could do this in your head. I understand. But the idea is to see if you can catch, the method. That's the thing. So if I did the backwards, right? If I did it the other way, if I did 5 plus 8, if I did 5 and I want to add the 8, can I add the 8? No, I can't. What do I do? To add the 8 is what? Plus the 10 minus the 2. We've done this before. 8 is equal to plus the 10 minus the 2. So I'm going to plus the 10. Oh, look, I cannot minus the 2. What do I do? This is where we do the other one. This is where we do minus the 5. So we're going to minus the 2 equals to minus the 5 plus the 3. So what we're going to do is minus the 5 plus the 3. My final answer is 13. So what I did here was minus the 2 is equal to minus the 5 plus the 3. What I did was called substitution, right? This is what I call a two-step equation. So if I was to put it all together, it would look like this. 8 is equal to plus the 10 plus minus the 5 plus the 3. That's what it would look like. Substitution. Yeah, I was thinking that it would be called associative property, but it's not, because it's the other way. Anyways, so why do I do it this way? The reason why is because I'm trying to show you that if I do 8 is equal to plus the 2 minus the 2, that's what it looks like, right? What we did is we substituted the minus 2 with this minus 5 plus the 3. This is what we call two-step equation. This is what I call two-step equation. In the abacus world, they call it mixed formula. But I'm trying to align it to algebra, right? Algebra does substitutions. Algebra does isolating the variable. Algebra does a lot of stuff, right? Oh yeah, I get it. I just take the difference from the front. Yes, exactly, Goblin, exactly. So if you notice, I minus the 5, I want to minus the 2. If I want to add the 5, I'm going to add the 2, right? So if I want to add the 2, I'm going to add the 5, and I take the difference. Yes, exactly. Exactly, right? But see, that's the thing. The interesting thing is, if you know how to add it, you will know how to subtract it. That's the cool thing about abacus. It's not another strategy. Once you know how to add it, you know how to subtract it. This one is this one. This one has all the formulas, and it's also erasable. And so this gives you the beginning part. It shows you the cumulative property, how to make a 5. And then these are all of the formulas on how to make a 5. And then, you sell all the workbooks? I do. So this is the one set. This is a laminated one, right? So then this is how to make a 10. Making a 10, I do it both ways. You know, there's the plus the 9, and then there's the plus, and then there's the minus. And then there is these, which is how to utilize, and I give you instructions how to substitute it. So the first thing you're supposed to do is you're supposed to isolate the variable, and then I tell you the instructions, and then from here you write the cumulative property, and then this is the sample question. So if I have 4, I want to plus another 4. What do? I substitute plus the 5 minus the 1. So I'm going to plus the 5 minus the 1. Yeah. Oh yeah, in my TikTok shop I have this one, which is Preschool Abacus. This one is bead recognition, which is the mazes, where you start going through and you figuring out what the number is, and then there's the path. Then I have, after the preschool one, I would suggest to do the plus the 5, which is this, adding the 5, specific numbers, specific questions of how to add the 5. And so that's what this is. And then we have minus the 5, which is my latest one. We minus the 5, and again, there's problems, right? There's specific abacus math problems, and I have my numbers, right? You find the answer, and then you answer what the secret number is, the word, and then again, there's instructions, right? How to make it, and then, oh yeah, these are all mine. See? Oh wait, where's my name? My name. I can't find my name. My name's there. So then after that, I have plus the 10s. And right now I am working on minus 10s. And so again, these are all very specific abacus questions. Very, very specific. So this one is the puzzle. And in the puzzle, you answer the question. And then here you find the answer. So what I was trying to do is I called you earlier, Live, and I liked it. Oh, thank you. Thank you so much. I appreciate that. So yeah, I'm on my 10th workbook, and I do sell it at the TikTok shop, but I also do sell it. Where else do I sell it? I also sell it, if you want to see my whole collection, it's over here. So yeah, but this laminated one is not on there. The laminated one is only here on TikTok because I laminate it. Yeah. And then it's cool. This is really cool because then here there's like little labels. I labeled it. I tabbed everything. So this is the plus 5. So you can just do a quick quick reference, and then this is the plus 10s. And then behind every plus 9, right, is the minus 9. If there's a plus 8 here, then the minus 8 is behind it. So it's easy to reference. And then You're also, and Nick, but wait, there's more. I also give you the abacus framework. So when you go through each number, you go through this pattern, you go through this checklist to see if you can do it or not. And that's it. This is adding and subtracting all in my, all one here. But I have the different activities for the kids to try to entertain them as well as to get them to enjoy it. You will get the answers in the back. Just in case you don't know the answers, I gave you answers in the back. But I like this one because it's like spin the wheel. So you use a paper clip, you spin it, and then it lands somewhere, and then you answer it. So cool. Oh, issues with. I think this could help. Oh yeah, I think it would help too. You might want to start off with. It's easy to move the beads. You might want to start off with the +5 and then the -5, and then after that would be the +10 and then the -10. So in mainstream, adding the 10 is like carrying over, is like doing the grouping and regrouping. That's what plus the 10 is. +10 and -10 is grouping and regrouping, if that makes sense. But in abacus world, we start with the 5 and then we build our concept, and then it's once you understand the concept of the 5, then we go into the +10s. So here I added these cats, 5 cats. There's 5 cats in a tree, and I was trying to make it so the kids understood. I didn't use money for this one. So I have 5 cats in a tree. My question is 3. If I add 3 on the abacus, you'll notice I don't have any more beads to add 4. I need to add the 4. So this is where the 5 cats in the tree comes in. 5 cats in the tree. I go to the 5 cats in the tree, and I grab 4 cats. 1 cat runs away. So my final answer is 7. That's how this was working. Yeah. And then this one was the cats. This one was flowers and petals, and it's still the same thing with the 5, but then we do the reverse. So here we do 4 minus the 4, right? So I show you minus the 4 is equal to minus the 5 plus the 1. Here's a sample question. 8 minus 4. So I have 8. Can I take away the 4? Can I take away the 4? I can't take away the 4. So what do? I minus the 4 is equal to, and you substitute it, minus the 5 plus the 1. So my final answer is 4. And then you have them write it again. The reason why we get them to write it is so then they can remember what it is. And then this is the spinning of the paperclip. You have your spinner, so it lands on 16. You write the number 16 on the evens or the odds, and here, right, I have 16. I want to take away 4. To take away the 4, what do? I have to minus the 4 is equal to minus the 5 plus the 1. Again, I wanted them to practice writing it, right? And so we do minus the 5 plus the 1. My final answer is 12. So because the kids are young, I would get them to understand. Because the kids are young, I would get them to just memorize this, if that makes sense. You could try to explain it to them, but I don't know if it makes sense to them to talk about this, if that makes sense. So it all depends on the age. I mean, you could try it. There's no harm, but I don't know if it would confuse them. Yeah? How are we doing? Any questions? Okay, yeah. Yeah, Goblin, these are all the ones that I made. I've been teaching abacus for 20 plus years. And so I just now started to publish books, and I started to teach online, and do you have a bundle for all of them? I haven't thought that far ahead. I apologize. I haven't thought that far ahead. Maybe later? I actually learned math on the abacus back in elementary. Oh, yeah. Hey, meme lord. Yeah, in one sentence, why should one use this over the methods of math? Around 1991. Oh, in one sentence, Abacus, you will know why you're using the numbers on the abacus. You're fine. I could buy it directly if that's easier to do a bundle price for all. Let me know. Okay. You know what? Send me a DM. Send me a DM, Stinky. Send me a DM. Let's talk about it. Do Abaci help with larger math problems? Yes. Yes, because it's all scalable, right? Because you know the fundamentals. If you know the fundamentals, when you know the fundamentals, it is scalable. It doesn't matter. You don't need to use the different strategies that are being taught in mainstream math. Yeah. So, Meme Lord, just so you know, like in mainstream math, is there a lot of memorization? Like you memorize what? Doubles, right? I don't know what else we memorize. There's a lot of things we memorize. We memorize a lot of things. If we were going to use a math tool to do math, why not use a calculator? Because a calculator is a black hole. Children that are 5 years old should not be using a calculator. Right? Why would a child at 5 use a calculator if they don't know what a 5 is? That doesn't make sense to me. Right? Does the right, Meme Lord? You know what I mean? Like it makes sense, but then that's the other thing. Like, do you work with jigsaw puzzles? Do you like to play with Sudoku? Do you like to play with games? What's the point of playing a game? You know, it's the same thing. You just die and you just go back again, right? Or what's the point of doing crossword puzzles and word searches? It's to keep our brains active and engaged. You know what I mean? Like I know what you're. I know it's. I know what you're. I know the question is very innocent, but it's a little bit. I get a little bit salty because I had a few people that come in and say, you know what, you're making it too hard, and it's resonating with me. So I'm not trying to make you be the bad person because I know you're not. It's just one of those things like it all depends. And that was the other thing, like, you know, they're trying to get old people to do Sudoku to keep their mind active, right? To keep to thwart off Alzheimer's. And I think that Abacus will do the same. I think the idea is that you can help yourself to do math in your head easier than visualize it. Yeah. I see. So it's more for people that generally just enjoy math and helping kids to understand. Yes, yes, I'm here to help the kids to understand. Although, a different view. It is a different view. It is a very different view, and I feel like that And the other thing that I notice is that in mainstream math, I feel like that they're complicating things that they should not be, like in 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 adding and subtracting, there's a lot of strategies. There's a one with the number bonds, and there's ones with number lines and so forth. But if you really think about it, the number bonds and the number lines are not giving the kids a physical thing, right? You could deal with the blocks, but then it gets overwhelming when it gets more than 20. You know what I mean? Whereas the abacus, it's all in the package, right? Oh yeah, no, you should. You should. And that's what people do in abacus world, right? The kids that do this, they see the abacus in their mind. If you can do it in your head with your fingers, then that's the same concept, right? So like I can do 1345, right? And then I can add whatever because I can see it and then I know what I'm doing. Whereas the numbers are symbolic. They're symbols. If you notice that these numbers are symbols. 4 doesn't really mean 4. This could be the letter A for all you know. You know what I mean? But we know this as a 4, but this 4 doesn't make any sense. So why 7 is on top and not 10? Because this is an example question, right? The question is if I have 7, do I have enough beats to add the 4? And then you go through this framework. So this is an abacus framework. Is there enough beats to add the 4? Is there enough beats to add the 4? No, there's not enough beats to add the 4. Can I add the 5? No, I cannot add the 5 because I'm already using the 5. Then, Can I add the 10? Yes, I can add the 10. Plus the 10 minus the 6. So my final answer is 11. Why only 7 at the top and not 10? It's not 7, it's 5. So when we look, this is all 5. 5, 5, 5, 5, 5, 5. These are all 5s. This is 6. This is 7. This is 8. And then this is 9. That's what this is. This is all 9s. So when we look, every place value, every column is a place value. Every column is a place value. So if I was looking at it, it would be 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, and then 10. Middle East, Asia, Mesopotamia, Greek, Rome, when they started doing business, Mesopotamia, and then it traveled all over the world. That's where it happened. Yep. So it goes from 9 and then becomes 10 in the next column. Yes, exactly. Yeah, 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, and look, 100. 100. Right? 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000. Or 1000, sorry, 1000. 1000, 2000, 3000, 4000, 5000, 6000, 7000, 8000, 9000, 10,000. 10, right? 1 0 0 0 0. Okay. Goblin. Yep, we're okay. How are we doing? So that's the difference between adding and subtracting 5. And that's what this is. Yep. Yep. Cool. Yeah, thank you. Oh, so do we want to go back to adding 5, or are we going to do more multiplication? Not sure why there's 7 rows, or is that irrelevant? That is irrelevant. Because I have one that's 13 columns, and then size matters. Because it just means that's just more numbers, right? So if I start here on my ones, thousands, millions, billions, trillions. If I want to track the national debt, I have 23 columns. Then I get more, right? It just depends on how big the number is. Every column is a digit. Every column is a digit. So it depends on what you want to do. Do you go from right to left? Well, yeah. That's how we do it in math, right? Ones, tens, hundreds, thousands, 10,000. Whatever you're writing is exactly how it is on the abacus. Yeah. However you write. I go up to down when I write my math. So are you saying I mean, when you multiply bigger numbers, if I'm multiplying Goblin, I go, if I am multiplying, we can do a bigger number. Multiplying, it is left to right. So if we did 23 times that, 23 4 times that by 56. Oh, you can't see that. Right? 234 times that by 56. Is that what we're talking about? So when we do it, we go 1, 2, 3, 4, 5. Okay, let's see if I get this right. Cause I move my abacus a lot, I might get this wrong. That's my that's my caveat. 1, 2, 3, 4, 5. So I'm over here. 5 times 2, because why do we do that? In new math, they do 50 times 200. But we don't need to do that. We just need to do 5 times 2 is equal to 10. Add 1, add 0. 5 times 3 is 15. 5 times 3 is 15. 1, 5. 5 times 4 is equal to 20. Add 2, add 0. I'm done with this. We go 4. 1, 2, 3, 4. 1, 2, 3, 4. 6 times 2, right? 6 times 2. 6 times 2 is 12. Add 2, add 1, add 2. 6 times 3 is 18. 6 times 3 is 18. Add 1, add 8. Add 1. Is there enough beads to add the 1? How do we know how to add the 1? Do we remember how to add the 1? Is there enough beads to add the 1? No. Is there enough beads to plus the 5? No. How do you add the 1? Plus the 10 minus the 9. Plus the 10 minus the 9. And then plus 8. And then 6 times 4, right? 6 times 4 is 24. 24. Plus 2, plus 4, plus 2. Plus 2 is plus the 10 minus the 8 plus the 4. So my final answer is 10, 3, 10, 3, comma, 10, what, 30, 1, 0, 4. That's my answer. Okay. So, why did I start in the middle? The reason why I start in the middle is because I have these ones indicator. These ones indicator is like my Pokemon.
Pokemon, I choose you!
So what I did is I chose this one. You can choose any one of these dot indicators to be your ones. I decided to choose the middle just because I like the middle. So I choose that one. That's why. Move the row over. Okay, yeah. So I got that. I asked the same question earlier. There's the little dots to indicate where the ones start. It's not a decimal. It's the ones indicator, in case you need to use decimals or whatnot. Yeah. Was your answer your earlier question? I was answering your earlier question. Right. So we have these ones indicator. That's what these dots are. They're not decimals. But here, if I choose this to be my ones, then everything else will be my decimal. If I choose this one to be my ones, then this would be 3 digits will be my decimal. This one has, right, I have a dot indicator here, or I have one over here. Every indicator is separated by a separated column separator. How do you add the 1 if there's no more room? How do you add the 1? So if I need to do 9, if I do 9 and there's no more room, this is where we have to make a 10. We know how to make a 10. This is where we have to memorize our formulas. Plus the 10, 1, 0, take away the 9. Yep. Okay. I don't know if Carter's still around. Right. I was just answering your question, but you didn't read it until a couple minutes later. Oh, Goblin. Okay, yeah. Thank you, Goblin. I hope you had fun learning the abacus. Alright. What are we doing? Carter, are you still around or are you gone? Maybe maybe it's time to do some division. So yeah, I don't know, Meme Lord? Can you do multiplication in your head? That'd be cool. Ah, I gotta go by just TMD with the question in the lower background. Yeah. Okay, yeah. Thank you, Stinky. Yeah, Stinky Bappy. Yeah. Depends on the number. Oh yeah. So like I was able to do this on my abacus, which I showed you, right? And so that's why it's versatile. That's why the abacus is versatile. I'm not saying that your numbers in your heads are wrong. I'm just saying that, it's scalable. The abacus is scalable. Cool content. Thank you, Hope. Yeah. Cool. All right. Let's do a review. For those of you that just came in, I'm not sure who came in, but for those of you that just came in, we're going to be reading the abacus. To read the abacus, it's 1, 2, 3, 4. All these beads are 4. Thank you. Thank you, Hope. So we have 4 and then 5. Anytime the beads are touching this horizontal bar, this is being counted. So this is 5. If I did this, this is 5, 5, 5, 5, 5, 5, 5, 5, 5. If I did this, this is 0. If I did this, this would be 1, 1, 1, 1, 1, 1, 1. 2, 2, 2, 2, 2, 2, 2. 3, 3, 3, 3, 3, 3, 3. 4, 4, 4, 4, 4, 4, 4. And then we have 5, right? 6 looks like this. These are all 6s. These are all 7s. These are all 8s. 8, 8, 8, 8, and then 9. 9, 9, 9, 9, 9, 9. So every one of these is 9. Every column is a place value. Every column is a place value. Oh, here it is. Nope, that's not it. Every column is a place value. I've lost it. I'm losing my marbles. I can't find my thing. I can't find my place value. I'm going to have to use this one. Alright, so every column is a place value, just so you know. Every column is a place value, like that. Ones, tens, hundreds, thousands, 10,000. I guess I would multiply 245 times by... Yeah, it's a strategy. There's many ways to do it. It's not just one way, right? Math is not just one way. It's just, how do you get to it? That's all. And the idea for learning abacus is to solidify your number fluency. And I know a lot of the kids have problems with their numbers, have problems with even multiplying. So, I just want to know how to use one. Oh, good. Did you need a review? Is that what we're doing? Do we need a review? Oh, here it is. We can review if you wanted to, if that makes sense. I'm just trying to rearrange my books. I have a lot of books. Oh, yeah. You know what? We can do a maze. How about that? Okay. So, when we do the maze, let's do this one. What number do we think this is? Hey, Ethan. Oh, excuse me. What number do we think that is? If I did this, we're talking about 2 place values, right? So we have this, and we have that. 55. Thank you, Ethan. Meme Lord. No. The top beads are 5. We'll always have a value of 5, no matter what. 5, 5. 5.5. No, not yet. Why? Because this is my ones. Hey, Aura, how's it going? So, no, Meme Lord, it's not 10. So when we look at it, user 114, we have our ones. If you notice there's a dot, there's a ones indicator right here. Because I have my ones indicator, I'm going to choose this one, like a Pokemon.
Pokemon, I choose you!
If you choose this one, then this would be your ones, your tens, but there would be no hundreds. Make sense? So when we're going to look, right, when we look, there's no more hundreds. So I decided to choose this one to be my ones, just like...
Okay, Charizard, I choose you!
So I choose this one to be my ones. After the ones is my decimal. The decimal sits between the ones and the tenths. Does that make sense? So this would actually be 55. Five, five. It would be 55. Here, if we do this one, we have this number, and then we have that number. What number do we think that is? 24. Thank you, Aura. Yes, 24. 24. 20, 1, 2, 4. 1, 2, 3, 4. Thank you, Apple. Why is it 24? Because I have my tens, right? My tens is here, and my ones is over here. So if my tens is 2, and this is my 4 in my ones place. 1, 2, 3, 4. Okay? 24. Oh, excuse me. All right. If I have that one and that, what number do we think that is? Yes, thank you. Thank you, Aura, Meme, and Apple user. Yes, 97. Because we got 90, 5, 6, 7, 8, 9, 5, 6, 7. 97. And then we have this one over here. Whoa. Yes, Aura. Thank you, Meme. So we have this one. We have that. What number? Thank you, Apple user. Yes, Meme. Pancho, welcome, Pancho. Good job. Aura? Yes, 16. So it comes down to here. So again, what we're doing is we're learning how to read the abacus. How does the abacus work? Hopeless leftist. What we're doing is we're learning how to read the abacus. So the first thing we're going to do is understand that every bead touches this horizontal bar is being counted. Thank you, Pancho. Thank you, Meme. So when we're looking, right, we have 1, 2, 3, 4, and then we have 5. The top bead will always be 5. We have 6, 7, 8, 9. Hopeless. Does that make sense? So after 9, we have 10. How do I know? Just as I have my place values. Every place value, every column is a place value. I have my ones, my tens, my hundreds, my thousands, my 10,000. So we did 40, 45. And so now I'm here. This should be easy. What number, I'm making green though. I want to design my own math tool. That'd be cool. You should design your own math tool. We need to have more math out there. Yeah. Cool. Right? 99. Yep, 99. 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. We have 99. So then we come down here. And what number do we think that is? Yes, thank you. Thank you, Hopeless. Thank you, Meme. Thank you, Aura. Yes, 79. 5, 6, 7. 5, 6, 7, 8, 9. So 79 takes us over here. And then, oh, what book is that? This is this book. It is this book. Yep. So we have this number and then that number. Really? I found that. Good job. Literally. Yeah, this is awesome. I'm so happy you guys are excited about this. I love it. I love it. Right? Because it helps with visualizing. So we have that, and we have that. What number? I'm getting them quick now. Yes, you are, meme. Yes, you are. 87. Good. 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 Oh, yeah. That one's from Fifth Element. Oh, I love that movie. Fifth Element. Good. Good. When Mila Jovovich, she goes, good. Good. I might have to do that. Every time you guys do, yes, I will have to find it. I'll have to find my sound bit for that one. uh, yes, 27. Good job, Hopeless. Good, meme. Good. Thank you, Aura. Yes, 27. What do we have here? We have that number and this number. 30, 1, 2, 3, 7, 5, 6, 7. Good. And then we're up here. Oh, last number. Last number. So we have this and then that. Almost hopeless. Yeah, 59. There you go, 59. Yes, 59 it is. It is 59. Thank you guys for playing. Oh, and so here's my other thing that I added was called a reverse maze. So this reverse maze, this is a you get the path and you have to look. I give you the path and you have to look at the number, and then because you look at the number, then you color in the beads. That's what I did here. So when you look, I have 54. I'd color in 50. I'd color in 4, and then you go to this box here. This would be empty. Then I gives me 96, so I'd color in 96, and then I come over here, and this would give me 29. So I need to look over here, 29, and then it would come down to here, and then you'd have to look. So I called this a reverse maze. Yes, we got this now. Thanks for that. Yeah, not a problem, user. Yeah, meme. Good job, meme. Well done. Well done. So that's what this is. Would you mind doing another multiplication? Yeah, let's do it. So we're just here for counting. Isn't there just a way to use adding? I'm sorry. Isn't there ways to use them for addition and stuff? Yes, there is. Oh, Pancho. Pancho is pushing the class way ahead. All right. Let's see how this goes. Let's see how tired I am. I started yawning, so that means I'm about done. I'm almost done. Okay, so we have 789 times that by 89. So, yes, Hopeless, we will be doing adding and subtracting, but Pancho wanted to do multiplication. So now we're going a few steps ahead, and now we're going a little bit more intermediate. I hope you can keep up, and if you don't, let me know, and I'll take it slower. So, the first thing we're going to do is understand where is our starting point. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. No, that's too small. 1, 2, 3, 4, 5. Okay, this will work. What did I just do? I counted my digits. The reason why I counted my digits is because I need to know where to put my numbers. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we're over here. Now in mainstream math, and they call it new math. The way they do it is in Abacus world. Okay, wait, sorry. 1, 2, 3, 4, 5. Okay, in Abacus world, what we're going to do is called distributive property. distributive property. This is what we're doing. They're starting to incorporate this in mainstream math as well. They're calling it new math. Now in new math, when we do 80 times 700. 80 times 700. The difference between new math and abacus is that new math has to write it down, right? Abacus, we don't need to. Why? Because the abacus helps us track it. So when we look, we only need to do 8 times 7. My multiplication table only goes to 8 times 7. So I don't understand why we're doing 80 times 700. So I do new math in my head. Those are the difference. Why not use the last of the row? I could use here if I wanted to, but I chose this dot indicator like I choose my Pokemon.
Pokemon, I choose you!
This is why I'm in the middle, because I have a ones indicator over here. That's the only reason why. It doesn't matter where you start. It matters where you start, because it matters where you put it, but you have to know where you start. So either you start here, I don't know if you could see, I have these dots. These are my ones indicator. That's what that means. Okay. 1, 2, 3, 4, 5. So what? 5. 8 times 7 is what? 8 times 7 is what? Even though the 8 is the 10s and the 7. Yes. Yes. It doesn't matter. I'll show you. What is 8 times 7? 56. Thank you, Aura. 56. See? I added 56. What does that mean? 1, 2, 3 zeros. 56. 56,000. I don't need to say 56,000 because I already have it on my abacus. You know what I mean, Hopeless? Does that make sense? I'm just putting in my product here. That's why we put it on the abacus. So I don't need to write it out. Ah, yeah. Right?
This is the way.
This is the way.
This is the way.
6 times 8. I'm sorry, 8 times 8. No, not 74. 8 times 8. What is 8 times 8? Not 74. 8 times 8 is 64. Thank you. 64. Okay. Because we bumped ahead, right? Because we bumped ahead, we need to start understanding how do we add the 6 and the 4. We need to understand how to add the 6 and the 4. Are we okay? Bear with me. When I add the 6, can I add the 6? No, because I want to be here. I need to add the 6. I know I need to, plus the 6 is equal to plus the 10 minus the 4. I can't be reading and then doing, okay. So plus the 10 minus the 4. I want to add the 6. Plus the 10 minus the 4. Plus the 10. Plus the 10 minus the 4. Minus the 4. We know how to minus the 4. Minus the 4 is what? Minus the 5 plus the 1. Minus the 5 plus the 1. And then we need to add the 4. 8 times 9. 8 times 9 is, what's 8 times 9? 8 times 9 is what? 72. Add the 7, add the 2. Add the 7, add the 2. Add the 7. Can we add the 7? No. Pancho, do you remember how to add the 7? How do we add the 7? Do you remember? Maybe this is too complicated for my first one. Yes! This is a little bit more complicated. That's why I was like, I don't know. But we will continue on. Go to the next row and add the bead. Yes. Plus the 7 is equal to what? Plus the 7 is equal to plus the 10 minus the 3. We will talk about the formulas. This is the formulas that we need to do. Plus the 10 minus the 3. Hey, John, a little bit. Hold on. Plus the 10 minus the 3. And then we add the 2. We're done with our 8. Oh my God. Pancho, you better still be here. Yes, Jasper. Yes, there is a pattern. Yes, good. Pancho, you better still be here. Because it helps with a 2-step. No, this is not 2 steps. There's only one 2-step. All right, 1, 2, 3, 4. 1, 2, 3, 4. I'm over here. 7 times 9 is 63. Add the 6, add the 3. Oh my gosh. Okay. 9. What is 9 times 8? 9 times 8 is 72. We said 72, right? 72. Oh, plus the 10 minus the 3. Plus the 10. At least Pancho is still here. Plus the 10 minus the 3. Plus the 10. Cannot plus the 10. I need to plus the 10 minus the 9 plus the 3. Plus the 10 minus the 9 minus the 3. And then plus the 2. I've lost myself. Oh, no, I'm good. 81. 9 times 9 is 81. 9 times 9 is 81. 81. Plus the 10 minus the 2. Plus the 10 minus the 2 plus the 1. Oh my God. Pancho. I pledged the masters to the abacus. I didn't. Ah! How do you know which one to use? Okay, before I forget, let me write down my answer. This would, 7, 0, 2, 2, 1. I don't even know if this is right. I'm so tired. You got me at the end where I'm like kind of tired. Okay. Let me see if this works. 7, 8, 9 times that by 89. Huh? Oh, good. That is the right answer. All right. Okay, questions. How do you know which is which with that? Okay, so Damien, what I do is I only work with the numbers, right, that I'm touching. So when I go, I'm only working 2 columns at a time. That's the reason why. So I know if I do 56, right, 63. I know I'm going to do 60, I'll do 3. 63, that's how I know. Pancho. We started with the 5th to the left. Yes, we did, because we did 1, 2, 3, 4, 5. We did to the 10,000 column. Maybe we should start with 2 digits. Yes, I think we should do it just 3 digit. We could do 3 digits. That would be easy. The magic of Abacus has kept the track of you, even though you got confused. Yes.
This is the way.
This is the way.
This is the way.
Oh my God, Pancho. Okay. Okay, I don't know who's come in. That was impressive. Can't wait for that level. Okay, thank you, Meme Lord, for all of the gifts. It took all my concentration to go through it. I want the new math in my head, but forget which numbers I had previously when it comes time to add them all. Yeah. All right. Who is still here? Anybody new? Let me know. Let me know if you are new, and we can do a review. And then after the review, we will do multiplication, because everybody seems like they want to do multiplication. You don't want to know what the foundation is. Okay, so the first thing we're going to do, it is hard to do it when you do it live is very impressive. Thank you, I appreciate it. Pancho! Okay, so thank you, Macy. So we're going to count on the abacus. We do 1, 2, 3, 4. 4. The top beat is 5. No matter what, this is 5. So we have 5, 6, 7, 8, 9. So after 9, we have 10. Now, how do I know? Every column is a place value. There we go. Every column is a place value. I have my ones, my tens, my hundreds, my thousands, and my 10,000. Does that make sense, Macy? I don't know if she's still here. Okay, good. Okay, good. So when we look, we can count by tens now. 10, 20, 30, 40, 50, 60, 70, 80, 90, and then we have 100. Whatever we write is exactly how we read it on the abacus. So if I did this is 5, 5, 55. If I did this would be 155. Now be careful, if I do this, I flicked too hard.
And flick. Oh, you flick too hard, damn it!
Don't flick too hard because your answers will become wrong. So don't flick too hard. When you look, you want to be gentle because the beads are pointy. And so what you can do is you can use your fingers, the edges of your fingers, to just move the beads. You don't want to be aggressive, and you don't want to, I mean, you could, it's not delicate, like it's made out of plastic, right? But you don't want to be aggressive when you do this because your answers will be wrong. The reason why is because it's very easy to move the beads. It's like a rattle. So you would use your left hand to stabilize the abacus. So I appreciate everybody opening their mind to me.
Now open your mind to me, please. Open your mind.
Which Meme Lord did. Right? So when we look, right, we can do, and I'll do more counting. It'll be 1, 1, 1, 1, 1, 1, 1. All of these are ones. And then we can do twos. These are all twos. Every column is a 2. And then every column here is a 3. Every column here is a 4. When we do this, all the columns, this is 5. And then we could do 6, we do 7, we do 8, and then we do 9. So that's how we count on the abacus. The abacus goes by place values. If you notice, there's these dots. These are the ones indicator. Hey, thank you so much for the GG tag. So if you notice, I have these dots. These are my indicators. This is a ones indicator. I can choose one, like a Pokemon.
Pokemon, I choose you!
And then I can do ones, tens, 100, thousands, 10,000.
Okay, Charizard, I choose you!
If I choose this one, then I move everything over, and I have my ones, my tens, my hundreds. But I have no more hundreds. I have no more thousands. But I have a lot of decimals. That's what that means. Okay. We're going to push forward to doing one more multiplication, and then I will sign off. Pancho, are you still around? Okay, thank you for being patient. Yes. Thank you, Hopeless. Thank you, everybody, for being patient with with the review. So we're going to be pushing ahead. There's supposed to be adding and subtracting, but instead people want to see multiplication. But there's a whole bunch of like adding and subtracting we should do, but instead we're going to do multiplication. All right. So the first thing we're going to do is understand, again, our starting point. Where do we start? How many digits do I have on my question? How many digits do I have on my question? I have 3. Right. 1, 2, 3. 1, 2, 3. So I'm going to start at the hundreds. No, I'm going to count all of it. 1, 2, 3. So again, this is what we call distributive property. What we're going to do is we're going to do 8 times 8. 8 times 8 is equal to what? 64. Thank you. I add 6, and then I add 4. Now what do I do? 8 times 9. 8 times 9 is what? 72. Okay, so if you noticed, I need to add 7 here. Thank you for the rose, Pancho. 34? No. So we need to add 72. 72. I need to add 70 to my 4. Is there enough beads to add the 7? No. I cannot add the 5 because it's a 7, right? So I need to add a 7. What is the formula to add the 7? Excuse me. What formula do I need? Thank you, Pancho. Yes. Plus the 10 minus the 3. Plus the 10, 1, 0, right? 1, 0 is 10. And then take away the 3. Add the 10, take away the 3. And then I need to add my 2. So if I add my 2, I'm over here. So my final answer is, 712. That's my answer. That's it. So the 72 is 1 place lower than 64. Yes? No. So when we're doing it, if you look, it's supposed to be like this. 640 plus 72. That's what it looks like. So if we're doing this in mainstream math, what we're doing is we're going to add the 2, add the 7 and the 4, which is what? 11, and then 7. But what we did in Abacus world is we understand that this is a 7 is equal to plus the 10 minus 3. Does that make sense? So we had 640. It's already on the abacus, 640. We're going to add 72. 72. 72. Add the 7. To add the 7, right, that's our add-in, we're going to plus the 10 minus the 3. Plus the 10, take away the 3. And then plus the 2. And then add the 2. So when we do it in Abacus world, we go from left to right. In mainstream, it goes from right to left, right? Or even still, when we do this, 9 times 8, what do? We do this first, 72, and then we do this, right? 640. And then we add it. But we don't need to write it out because we can do it on the abacus. Hey, Eve! After this, can we do it? Well, 3 times 7 would be additive. So I'd be 7 plus 7 plus 7. That's what I would do. So then we would know that when we add 7, we want to add another 7. It'd be fun, not like a calculator. Right? To add another 7, what do? Plus the 10 minus 3. Plus the 10 minus the 3. Cannot minus the 3. Minus 3 is equal to minus the 5 plus the 2. Minus the 5 plus the 2. So then we got to add another 7. How to add another 7? Plus the 10 minus the 3. That's what I would do. Right, Eve? So the difference is in Abacus we would have to do cumulative addition. Yeah. Yeah. It only works, Jasper, roll up your math class with the Abacus, it would be the coolest. So it works better if we had 3 digits. So we could do 7 times, 73. Let's do 73 times 3. We could do that, right? So 1, 2, 3. But then we'd have to remember, see, we have to know our multiplication, right? 3 times 7, 7 times 3 is equal to 21. Add the 20, add the 1. 3 times 3 is equal to 9. 9 is a single digit, so I'm going to make it 9. So I got to do that. So my final answer is 219. 219. You know what I mean, Eve? Yeah. So I mean, it's good because you can do critical thinking, right? And it helps keep your mind sharp. The simpler ones definitely help a lot to solidify. Yes. You said no calculator. You didn't say no abacus. Yeah. I appreciate. Oh yeah, not a problem, Hopeless. Yeah, not a problem. It's helpful, but that's what it is, right? Like, in the next class, I go through talking about the specific formulas, right? Because the formulas is what really matters. We need to know how to make a 10, and we need to know how to make a 5. If you know how to... Hi, E. If you know how to do all of this, anything that you add and subtract can be answered by this. But I do apologize. I am going to sign off. I've been on for a little bit, and I'm getting a little tired. Hey, Copper! I apologize. I'm going to sign off. Do you have a YouTube videos or something you mostly stream? I mostly stream, yes. I just got here. I apologize. Hopeless. My link is in the bio. My link is in the bio. I have a free reference sheet that if you want, and I also have my YouTube channel there as well. So this is the Big Brain Notes, like a reference sheet on like how to read the abacus. Yeah, I apologize. I'm so sorry. You know what? I will be on. You earned the Poncho. That's one way to bring the class up ahead, right? Yeah, not a problem, Hopeless. I'm trying to. So I'll be here again 8 a.m. Pacific Standard Time. So I'm becoming more scheduled. So here's the schedule I'm trying to do is I'm going to do 8 a.m. Pacific Standard Time, and then I do 8 p.m. Pacific Standard Time. True, very true, Poncho. Huh? So those are the 2 times I'm going to do. And I do stream everywhere. So like if you go on YouTube right now, I'm streaming there. Yeah, see, it's 1 a.m. That's like crazy late. I don't know why you'd be mathing in the middle of the night. I'm trying to be a little bit earlier. Yeah, right? Like it's 10 o'clock. So you started at 11. Yeah. Like I'm trying to start earlier. Midnight math. Night math, not midnight math. It's midnight math for Aura. Yeah. So, but yeah, like, you know, my YouTube, what do you, what, you don't do math in the, you know, that's funny, right? Like, you guys are willing to stay here and just learn math. ah, finish up AP Calc, and my God, it was light until I got to the FRQ. I don't know what FRQ is. We all do. Eve, that's funny. I don't know what FRQ is. I'm sorry, Dylan. That's above my pay grade. AP Calc is above my pay grade as well. It's AP talk. Yeah, that's like like somebody asked me like if I did trigonometry. I'm like, that's above my pay grade. Or the other one was integrals. I'm like, nope, above my pay grade. Sorry. You know, ask me about anything arithmetic. Arithmetic. If you can make a calculus question arithmetic, then I can tell you how I answer it. All right. Thank you everybody for joining. Thank you Dylan for commenting. Thank you everybody for sticking with me for the multiplication question. I don't think you can do integrals with Abacus. I don't even know what integrals is. How long have you been streaming? I've been on for 2 hours now. I'm gonna go to sleep. Thank you, Aura. Thank you so much. Have a good night, Eve. Yeah, I'm gonna try to be here a little bit more earlier, right? So these are my hours. So I'll be here again at 8 a.m. I'm sorry. I'll be here tomorrow, 8 a.m. if you can join. Yep, 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 yep. Not a problem. So these are the times I'm going to try. And it'll be, you know, Monday through every day. It was my last day of high school. Oh, congratulations. That's a really cool thing. I'm mountain land time, so I don't know the difference. Oh, I don't know. Right now it's 10 o'clock. So 2 hours would have been 8 o'clock. Yeah. Are you going to go to college, Dylan, or are you going to go get a job? Oh, it's when? Yeah. So 2 hours prior. So, what, 9 o'clock? I'd be here 9 a.m. for you. Oh, congratulations. Good job. Go to college. Oh, go to college without debt. Don't go into debt. Just so you know. Don't go into debt. If you can go to college without debt, that's the best. You don't want to start your life being in a debt hole. So, good luck to you, Dylan. Good luck. Yeah, it's only 2 years. Oh, yeah, there you go. See, that's smart. I'm in college now and it's hard. You know, you just need to study more. Yeah, my kid, I have 3 boys, and he's gonna go to college as well. He's gonna go to East LA College first, and it's free, and then he will transfer to wherever he wants to go. How do you do college without debt? There's many ways to go through college without debt. Yeah, better study habits would be good. It's hard. You need to take the time to study. You know what, Janae? Think about why are you learning it, right? FSA helps a lot, and scholarships helps. Scholarships helps. You be careful with the FAFSA. FAFSA also puts you into student loan debt, and you don't want that. Hey, Bill, welcome back. Eve, it's not always possible, but community college for your associates is cheaper. Yeah, I'm in college too, and I'm in 30. Yeah, it is possible. It is possible to do it without. One is to go through state school, right? 2 is to go through community college, right? And so FAFSA paid everything for me. But FAFSA paid for everything, but is that considered student loans? Right? I just filled out my FAFSA. I did community college route in July. FAFSA is debt. Yeah, you have to be careful with FAFSA. FAFSA is a student loan. Be careful. Be careful. Now we can talk about finance. I'm so I'm very lucky. I was never in debt. Yeah, you have to be careful. Only pays like 5,000. It usually doesn't pay for everything. Yeah, Yeah, I mean, there's many ways to go around it. Scholarships, keep applying to scholarships. There's been a bunch of people that I know that they applied to scholarships, some random scholarships. They got them and they were able to, get them paid off. You can also go to work as well, right? You can work part time or what have you. Yeah, but you know what? It's better to pay out of your pocket than it is to go into debt because you don't want to have to pay for that interest rate and you don't want to have to be paying when you get out. So, are any of your boys going to NUUC? Right now, they're not old enough. Right now, my oldest one, this is his last year in school, and he's going to go to community college. So, because he's going to go to community college, it's free, and then he's going to transfer to wherever he wants to go. So, if he goes to state, I think he's going to go to either Cal Poly or SLO. I don't know if he wants to go to UC, but even UC is still affordable, right? But it's affordable after you do your general educations in the community college. California is the best because we have community. We have the state funds. So much harder these days. It would be possible to earn enough money. It would be. It depends if you do state colleges or state colleges. Got to make sure it's not a loan through FAFSA. Yeah, only state or government. Yes, exactly. So it was a grant, right? There's a grant, and then there's scholarships. In Texas, FAFSA will pay for your nursing, but you have to finish it or then you pay. Oh, that's interesting. Yeah, see, I don't know about I don't I only know California because I'm in California. And so, yeah, FAFSA, I remember yeah, FAFSA still you have to pay. FAFSA is federal, not state. Yeah, but FAFSA, I don't know. Yeah, I guess. Yeah, that's true. FAFSA is federal, not state. But it also depends on what state you're in, right? Um, and the debt that you would incur. So, again, just be careful with the debt. You try your best not to go into debt, right? If try your best not to go into debt. I implore you that you don't want to be one of those that you're in debt. Like, I know so many students that are in debt like 80, 90, like like 100, what is it, 100, $400,000 in debt. Maybe do a math class on why interest is so bad. Yeah, I could. Um, but yeah, it's just one of those things like you don't $400,000 in debt. That's like a down payment for a house. You know what I mean? Like, let's just gamble, guys. Yeah. I'm okay with this. This is fine for me, but I can't do any more math right now. Yeah, I see. Yeah, you just be careful. Be careful with your money. Kids just get told it's only one way and don't know any better. Yeah. Yeah, and it's also the parents too, right? Like, we don't know. When I first came to America, like, so I actually grew up in Canada, and my parents didn't know anything. And so it was hard for me to, like, navigate through. Luckily, I didn't end up with debt. But then that was a long time ago, right? And so I was lucky enough to not go into debt. My husband is born here. He's Chinese as well. And he was able to get out of school without debt. But what did he do is he did community college and then he went to Cal State. And then after Cal State, with Cal State, he could have a job and still go to school. It took him a little bit longer, but at least he didn't go into debt. So when we married, we were able to, start our life without any debt. So try your best not to go into debt. Things are different. Things are different, but you know what? It's also how you see it too, right? There are many ways. Like in California, you could go to community college. Jobs don't pay enough for college anymore. It depends on what kind of job, right? No, it's math. But there's many ways, but we don't need a traditional. I'm I still want my kids to go to college just because I want them to understand how to, think procedurals and all that, and know expectations, right? I don't want them to be stuck. And I don't think they could be motivated to learn on their own, but to each their own. And so, have you ever heard of the prop firm trying to do that right now? I don't know what a prop firm. I don't know what a prop firm is. Like, is that interning? Interning is good. Try to intern. My God, there's still 33 people in this room, and we're talking about finances. I just want you guys to not be in debt. If there's any way you guys cannot be in debt, you know what I mean? Try your best not to go into debt. Or minimize the amount of debt you go. Hey, RTX. Hello. Once again, hello. We're just talking about student loans. I was done. I was going to sign off. I applied for some scholarships and grants, but never. That's fine. But you know what? Apply for other ones too. There's so many out there. This is very apt timing for me. Oh, thank you. Thank you. I appreciate that, Eve. And I appreciate everybody that is in the room. Like, there is no judgment, but if you can try your best. So Beal, I would try to find other scholarships. Oh, there was one scholarship my nephew took. It was about his mom is a single mom, and they're a part of this community, and they had a scholarship, and he just wrote an essay about how being raised by a single mom had really helped him. You know what I mean? So there are lots of scholarships. From what I hear, I didn't do the scholarship route, but from what I hear, there's agencies, but check it out on the internet to see what else other scholarships are out there, even the strange ones. Nobody should go into debt for college. Basically, every other country wants to educate its people. Prop firm is just using people's money on stock, and if you oh yeah, I don't do stocks. It may be hard. It will take effort. It is worth it. Yeah. I don't I don't invest like that, Dylan. I do the safe route. I just do the, like, QQQ, or what was it, SPY. I don't do any of that stuff. I don't know. I cannot tell you anything about that. I would be cautious. I would research a little more. Yeah. It is hard. Oh, thank you, Hopeless. Thank you. Have a good night. Have a good night. Have a good night. I hope everybody does well. So, keep trying, Eve. Keep trying, Beal. Keep trying with the scholarships and the grants. That's the other thing, right? Graduating in 5 days. Oh, you gotta get those crazy lays. That'd be cool. I gotta make some lays for my son. So I was gonna make a instant noodle lay that he has to wear around his neck. You should get a instant noodle lay. That'd be awesome. I think Spam would be too heavy. Yeah. Okay, Dylan, I'll see you later. Congratulations. All right. Thank you, everybody, for joining. I will be signing off. I've been on for a little bit. But thank you again. I appreciate all of the comments and compliments and the comments. And the participation. Thank you guys so much. I appreciate you guys. And I will see you guys all in my next live. Oh, just so you know, my next live. Pacific Standard Time. I'm planning to come back on 8 a.m. and then I'll do it again at 8 p.m. So, I will see everybody. I'll see you tomorrow. Bye, everybody.